Hello, it's good afternoon to all participants on this fourth day of our NanoSafety training school. I hope you're all well and healthy and still fresh for some new interesting content today. And the first session today will focus on risk assessment and management. And our lecturer is Alex Zabeo from Green Decision in Venice, Italy. And he is also part of many EU-funded projects like Biorima, but also others. And he will give you a very nice lecture and introduction on risk assessment and management. So Alex, the stage is yours.
Hi, I'm Alex Zabeo from Green Decision, and today I will present you a decision support system for risk assessment and management of nanobiomaterials used in medical devices and advanced therapy medicinal products. The agenda for today includes the introduction to what a decision support system is, then a very brief explanation of the Biorima project, followed by an explanation of the Biorima decisional framework, which is implemented in the decision support system, a small example of what the Biorima decision support system can provide, and finally we will conclude our session with a training directly with the tool. So, what is a decision support system? Basically, a decision support system is a software, an information system that supports decision-making activities. The way it does this is by aiding the users in making decisions about unstructured and semi-structured decision problems, as well as dynamic problems. It means that when problems changes continuously, having a tool that updates its contents according to the new situation and proposes updated solution is useful. And also in situation where the structure of the information is unclear, being forced to structure it into a software tool that then can apply clear and transparent rules, this would allow for taking informed decisions. Let's now take a look at what are the main advantages of structuring decision making. First of all, it improves objectiveness, meaning that you will look at your problem in an objective way because it's completely based on data and not on your personal behavior. Then for sure it decreases uncertainty because it forces you to include your data in a clear way, and when uncertainty is still there, it's possible to visualize it and understand how to reduce it. Then it allows for repeatability, meaning that you can rerun the software every time information changes. Also, in some situations, it can be real-time decision making. Then it fosters transparency. This is useful because decisions are usually impacting other stakeholders, and having a transparent way of making decisions where you can also demonstrate why you got to some decision and which are the data used for that helps in avoiding conflicts in big groups of stakeholders. And this brings us to the next point. When there is a group of decision makers, having a decision support system will simplify group decisions, allowing all the stakeholders to work on the same project and see the same results and decide all together with specific tools which alternative to choose. And finally, it's important that it forces coherence, so that whenever the user is asked to answer some specific questions and give some weights to different aspects of the problem, this will be coherent alongside the different alternatives and in time. And this is something that is usually difficult to obtain without an automated system that can check the user inputs. In the specific case of nanoform related decisions, we need some kind of decision support system, basically because nanoform related data is much more complex than that coming from standard chemicals, because it changes according to several parameters and in different situations. So having a tool allowing to take informed decision is necessary. Also, the data sources are a few, so there is a limited availability of highly well-curated data. And some sources are poor in quantity or in quality, and this is another issue that needs to be taken care of. Also, regulation documents about nanoparticles and nanoforms are relatively recent, and they are updated constantly. And so trying to stay in line with regulation is not so simple, and again a tool can help in that. What happens now is that procedures are usually not really structured and basically delegated to experts, so that the same nanoform can be assessed in very different ways if you refer to different experts. So all of these reasons lead to a need for structured decisional process. So the specific aim of today is demonstrating and trying to use the Biorima DSS. Before that, let's take a look at the Biorima project itself. The aim of Biorima is to develop an integrated risk management framework to be used for nanobiomaterials in medicinal products and medical devices. To this end, the Biorima DSS has been developed. This is the software implementation of the framework. It's been developed as a web application, and it implements the integrated risk management framework. The DSS is addressing several life cycle occupational risks related to the production of nanobiomaterials to be used in medical products and medicinal devices. And we will now take a look at the contents of the framework. Basically, the Biorima decision support system allows the comparison of different alternatives for the production of the same good containing nanoparticles and nanoforms. Not only this, in the tool it's possible to specify the application of different risk management measures alongside different life cycle stages in the development of the nano-bio-enabled product. And this allows to compare different working conditions that could bring to the production of the same good in order to decide which one is the less risky for workers. To this end, risks are calculated, and this is done in a probabilistic way, so that uncertainty is fully taken into account in the whole chain of action, bringing to the final assessment. The assessment of risk is performed by integrating exposure and hazard data. And for this, the tool also embeds several in silico models which can be used to generate missing data, both related to exposure and hazard. Let's now take a look at the decisional framework and the data structure that is used in the decision support system. On top of the data collecting structure, there is what we call a project. A project is a folder, a container for all the information related to the product we are developing with nanobiomaterials. So a single user can have several projects, and these projects can be shared among users in order to work together on the same nanobiomaterial based product. Inside a project, we can find several development scenarios, which means that I can produce the same good containing nanobiomaterials, and I can also create nanobiomaterials in different ways, but they still have the same use. And I might be wondering which way of producing my product is the less risky for my workers. So for each different way something can be produced, we can have different scenarios. So in this way, these scenarios are something broader than simply exposure scenarios, because also changes in the formulation, for example, of the nanobiomaterial generate a different scenario, even though maybe the different work activities could be the same. Then, inside each scenario, data is divided in the environmental and occupational part, so that we can evaluate risks both for the environment and for the workers. Inside these two different ways of assessing risks, we always have information about exposure, so environmental exposure and occupational exposure, and about effects in the environment and hazard posed to workers. For each of these data that is needed by the decision support system, in silico models are provided to generate the information. Let's take a look at an example of what is available inside the decision support system. For example, we can generate probabilistic dose response information for human health of our workers. So by uploading data to the about experiments, we can have an automatic fitting and a derivation of a benchmark dose value that can be used alongside with, for example, data about exposure. In this chart, instead, we are seeing results from a probabilistic species sensitivity distribution that can be used in the environmental setting. And again, you can see we have the complete display of results from where we can derive the thresholds to be used to assess the risks both for human setting and the environment. Then we also have information about exposure, for example, probabilistic exposure for human health and for the environment. So by generating this probabilistic data for hazard and exposure, it's possible then to integrate them and obtain a probabilistic risk, which we will talk about later during the evaluation with the use of the decision support system. And finally, it's possible, if we have some risky conditions, to try to apply different risk management measures and generate several production scenarios to then be compared and see if the application of some risk management measures can resolve the problems and the risk posed to the workers or the environment. So that concludes this first part of the meeting with the general information about the decision support system. Obviously, if you need more information, you can write me at alex.zabeo@greendecisions.eu. And now we can take a look at the Biorima decision support system by logging in into sans.gd. Thank you for your attention and goodbye. Okay, thank you for the video. Good afternoon, everyone. I'm Alex Zabeo. This introductory presentation was just to explain the ideas behind the decision support system that we are seeing today. Then now we will have a demonstrative video of the use of the decision support system. So this is useful for you to understand generally how the system works and the type of results you can create with that. And right after that, we will have a hands-on training. So we will try all together to perform some assessment on a fake case study. So take a look at the presentation that's coming, and then we will meet again for your questions about the system and for the hands-on training. Thank you. So Sharon, you can go with the next one.
This that you're seeing now is the landing page of the Biorima DSS that you can reach by navigating to the sans.gd website. As you can see, this web application is divided into parts, and we will see afterwards. And today we will only work in the Biorima red part.
First thing you should do is to sign up to create your user. Let's see how it works. I click the sign up button, I input my name, my email, and a password. So now I need to verify my email. Once your email is verified, meaning that you click on the link you received in your email, you will be redirected to the first page inside the SANS DSS. First of all, you dismiss this information that you are a verified user.
The first thing is I have to choose which kind of assessments I want to perform. You can see on the left side we have nanomaterials used in consumer products, and on the right side nanobiomaterials used in medical devices and ATMPs. So today we will look at this Biorima related part. Again, in Biorima we have two parts, two types of assessments. One is related to IATAs, and the other one is the risk assessment and risk control part. The IATAs part is still under development, and today we will focus only on the risk assessment and risk control. So this is the first screen of where we have proper inputs to give, and we can see that we are landed in the project selection page. So in this page, you have a list of all your projects, and the project is defined as something like a folder where you collect all the assessment information related to some kind of product which contains nanoparticles. In some cases, the product can be the nanoparticles themselves, if you're a producer of the nanoparticles. Inside the project, you will collect all the information related to this specific project. So as you can see, the name of the project should explain the content. You can also see here that I already have 2 projects in my list, and that both were created by my colleague Virginia. And this is because you can also share projects with your colleagues, and we will look forward into it next. So Virginia created this project just for today, for the webinar, for example. As you can see, we have some buttons here. We can duplicate projects. If you have something very similar, you can duplicate it and then modify. Obviously, you can delete a project and then you can enter the details of the project, but we will see this at the end. So let's look at what can we find in a project. Once I enter the project, I get in the assessment context section. So here we have a list of assessment contexts. So an assessment context is something a bit broader than an exposure scenario. So it includes exposure scenarios, so ways that, for example, workers perform the work, but it's broader in the sense that it's different ways you can obtain the same product. So you can produce your nanoparticle or your product containing nanoparticle in different ways, meaning that you can perform different actions or different jobs. You can also use different nanoparticles or apply different risk management measures. So every time you have something different in the production that you want to compare, you can create an assessment context and then compare them according to human health and environmental risk assessment in order to understand which is the best one in this regard. And this is the main aim of the tool, the ability to assess and compare different contexts. But let's go back to the list of projects and try to create an empty new project so that you can see what happens in this case. So I give the project a name, for example, sunscreen cream. I can also add an image, for example, like this, and create my new project. So as you can see now, we have a new project, and this one is created by me about the sunscreen. So what happens when I enter in the assessment context part? The system is telling me that I must create an assessment context. But first, I also have to fill in to decide what I want to assess. And this is done through the assessment tree. That's what we will see now. So in the assessment tree, we have the occupational and the environmental branches. Each of those is then built on different life cycle stages. So we have a synthesis, product manufacturing, use, end of life. And inside each life cycle stage, we have different routes for the occupational setting and different matrices for the environmental setting. So for this example, we are probably manufacturing the sunscreen. And we are interested, for example, in evaluating the inhalation and the inadvertent oral parts. And as far as the environmental, we would take a look at soil and water. So I keep this simple for the example, but you can select as many as you wish in order to be complete. Once I'm done with the tree, I create my first assessment context. So this might be something like filling. So the more detailed I am in the name of the context, the easier it will be to differentiate between the contexts. You can see that we can also supply more information about the context. For example, the nanomaterial characteristics, like something like this. So this is just textual information. It's not used by the system as it's still not necessary to run the models. So the different inputs of the models only rarely require characteristics, but we are planning on adding also that. So we can establish different characteristics for the product, the process, and the operational conditions, and this would help again in differentiating the different contexts. So now the system is creating all the tables necessary for this context, and we have our first context. So we can always go back to the tree and modify it as we wish, and the system will update. So once we enter in the context, we can see we have two sections. One is related to risk assessment, and the other one is related to risk control. The same sections you can find in the left side menu. So let's start with the risk assessment part. We can see here that the risk assessment is divided in environmental and occupational. And both are divided in the exposure and effect, or exposure and hazard. So once you specify these two parts, you get the result about the risk that you can check in the results page. So let's see what's in the occupational exposure page. What we can find here is that we have one row for every branch of the assessment tree that we enabled previously. So we are in the product manufacturing life cycle stage, and we enable only the inhalation and inadvertent oral routes. That's why we have only these two rows. On the right, you can see the part where we can establish the value for this, for the inhalation of the product manufacturing. We have some buttons here. So we can just state that there is a negligible exposure, meaning that we are sure there is no exposure and we don't want to input any number. So we can just click here, and you see that this row became white, meaning that the value has been inserted. You can see that it was inserted manually. This is as opposed to calculated by a model that we see now. So another thing we can do is we can change and say that we have a deterministic exposure. So in this case, I can input a single number that I already know related to the exposure, or we can deal with probabilistic exposure. And again, if I already know the value, I can just input here, and we can input in different ways. So I can say it is something between 0.5 and 1, and this is a lower and upper confidence limit. You can see that the tool already computed the probability distribution for this. Or I can transform this in mean and standard deviation if I have these values instead. But what happens if I don't have the values? I might want to calculate them, and for this I can use a model that is embedded in the DSS. So by going to this green icon, you can see we have two models, one for exposure derivation of the oral route and one for the derivation of the inhalation. So let's see what happens when we enter here. So this is similar for all of the models. We have a page with all the inputs required by the model. So on the left side, we have the definition of all the inputs. And as you can see, we already provide default values for everything. These values are the most general ones, so you might be happy with some of them remaining as default, but you should definitely change the ones that are different in your environment. So once I input all of this, I can run my model. So we see many things here. The job has started and the exposure has been derived. We have an immediate result here, reporting near field and far field concentrations. And I also have this new badge here saying that I have one new model run. So in this page, I have a list of all the models that I ran in the past with the final condition. So the model run, I can go back, and the system selected the exposure from the model result, and you can see that now the data is computed by a model. Same thing I can do for the inadvertent oral. So I click and go inside this model. Again, you have the definitions, and you can see that for specific parts that might require more detail, you can just over your mouse and see the description. Again, we have a lot of information here. I just decreased the number of simulations to make it faster. And you can see that for every model, you have the reference in this bottom part, so that if you need more information, you can always go and give a look. Now I can also run this other model, and we can see, as this is a probabilistic model, we get again an instant result, but with a probabilistic interface, and we have lower and upper bounds of the exposure. So at this point, we have both. So let's move to the hazard part. The interface is quite similar, but not exactly the same. Anyways, we have the two rows related to inhalation and inadvertent oral. In case of exposure, it's the same model that we can run. And also in this case, we can say we have a harmless or harmful effect, meaning that we don't have to input numbers. We just say it is sure that it's harmful or not. We can have a deterministic value, or we can go for the probabilistic, but more interestingly, we can run the model. In this case, we are not directly in the model input page, because first we need to set up biomarkers. This because for the same route, in this case inhalation, we can have different biomarkers expressing the dose response for this thing. So let's suppose I decide for repeated dose toxicity, and I can see this. So I create this biomarker, but then I can have more than one. So I can and do something like this. Obviously, you can have as many as you wish. So now we have two biomarkers representing for this route. We can select each of those. We can directly input the data, or we can run the model. So let's see what's in the model. So we don't have any point of departure, so we have to estimate it. And this is the inputs required. These are very limited inputs, and then what's required are dose response data. You can input these manually or just upload a specific Excel file. Let's see how it works. So I can download a template of the file that I can fill in and then upload. So now that I uploaded the contents, you can see they are in table, and the run button is enabled. So I can run this model too. This will calculate the BMD. So what we got now is the benchmark dose evaluated, again in a probabilistic way. And now I can move to the next section, to move from benchmark dose to derive no effect level. So in this part, we will apply assessment factors. We have, again, all the inputs here. We have assessment factors here, and we can also add other assessment factor extrapolation aspects if we want to. Also, here we have a part where the data from the previous model is import. We can decide to change it if we want. So again, we run also this model and we get the final DNL results. So now I can go back. I don't know if you're writing something in the chat. I cannot properly see it when I'm sharing the screen. So if there's something going on, please let me know by saying something. So what we see now is that in this biomarkers page, we have the results of the first biomarker we evaluated. Now for the second one, let's say we already have the value. And so we input. And we can see it also appears here. So now we need one of the two to represent the whole inhalation route. So the system automatically decided for the one with the lowest DNL value, but we can decide for something else. It's up to us what we want to keep. So now that I selected one, I can go back and you can see it's here and it's derived by the model. In this case, instead, I can input data manually. And that's it. The system computed the probabilistic shape. So now that I input all my values, I can directly go to the result page and see what happens. So we have here the occupational in the product manufacturing, that is the only life cycle stage for the inhalation. This exposure is a deterministic value. We can see this, but we can also examine the different concentration in time. So this is not a probabilistic model as it is a time model, it's evaluating in time. We have the near field and far field and the selected exposure. At the same time, we can evaluate the hazard. So this is the hazard model we selected. More than the DNL, we can also evaluate the complete fitting of the model to our data points, the distribution of the benchmark dose, and the sources of uncertainty related to this. Finally, what we can do is evaluate the risk generated by exposure and hazard. So we get to this chart, where what we see is the distribution of the risk characterization ratio, which is basically exposure divided by hazard. So every time exposure is greater than hazard, we have a number that is greater than 1. So what we have here is that this line is establishing where the 1 is, and we can see that the complete curve is above 1. In fact, it's also easier to just look at the position of this line. So if the red line is in the red zone, it means we have risks. If it is in the yellow zone, it means we should try to reduce uncertainty and understand if we can move out of that. If it is in the green zone, we are quite sure there is no risk. Below here, we also have all the statistics related to the curve we are seeing. We can also compare directly the two values. So we can see that the exposure is far right from the hazard level from the DNL. And also here we can have a detail on the sources of uncertainty. And we can also do the same for the other route. So for the inadvertent oral, we have a probabilistic distribution of exposure. We have the probabilistic hazard, but without the model, so we don't have the other interfaces. And again, we have risk. In this case, you can see the red line is in the green part, meaning that all the risk is below 1, the risk characterization rate. Let's see what's in the environmental part. It's very similar to what we've already seen. So we start with the exposure. We see now that we have product manufacturing, soil, and water. The interface for the data input is the same. So what's interesting are the models. So again, in this case, the model is the same for all the compartments. So when I enter, in reality, we have two models. One is PFMA and the other one is the FATE model. So I want to apply both. So in this material transfer model, this is a bit complex. So this is the overview of the model. So you can take a look at it and check all the boxes that are. So you can see that the nanomaterials are moving from one box to the others according to some coefficients that you can specify. So the main inputs here are the total mass per year, the uncertainty, the number of simulations that obviously has decreased, and then the volumes. So the volumes we have input by default are the ones for Europe, but of course, if you want, you can change. And this means that if you input the production for your country and then the volumes for your country, then it will be country specific and no more Europe specific as it is now. And also down here, you have the steps for the coefficients where you can go and change literally every coefficient in the tool. This is really something you should do if you know what you're doing, let's say. And you always you should check the reference here if you want more details. So once I run this model, the model gets here, and you can see now, because this is a bit slower than the others, we can see in the jobs page how it is performing, and now it's finished. So I can go back here and know that my specs have been derived. So what you get in the end would be a probabilistic value here, like this. And the second part would run the same model, so it's exactly the same. So let's put also here some values. And so we now have evaluated our exposure. Let's move to the effect part. In this part, we can see we have a selection of two models. So the system is able to manage several models. So in the future, we might add also other models to the other parts. So as of now, we anyway consider a default model, the NSSWD model. So let's see what's in there. So I say that I don't have the data. I want to calculate them, and that I have a decent quantity of data points so that the model can run. So again, here we have a number of inputs we can change, and again, we can upload our Excel file. Okay. Now you can see all the data is being reported in the table here, and you can also go and change if you want. And you can obviously run this model. The model completed, and we got the probabilistic distribution instant result. So very similar to what we had beforehand. And the result is here. We can run the model again here, but it's basically always the same thing. So I will skip and generate. Again, we can go to the results page, and this time we move to the environmental setting. And you can see that now we have the environmental metrics here. Again, we have probabilistic exposure, we have the probabilistic effect with all the details of the SSWD, so the species sensitivity weighted distribution. The comparison between the Pnex and the uncertainty. And finally, also in this case, we have the same risk evaluation, so risk characterization ratio, and always if the red line is in the red part, we have some risks. Again, we can compare the two curves, and we see that the fact is always on the right side of the p-net, and that's why we have such risk. And also we have different sources of uncertainty again. So up to now, we've been working in the risk assessment part, but let's see what's in the risk control. So as I was saying in the beginning, the idea is to compare different assessment contexts. So that's why we have this comparison tab here. In this moment, the tab is saying we only have one assessment context, that is this drilling silver, and we only evaluated the product manufacturing life cycle stage in the occupational and environmental. So the system already integrated all the information about the risks and decided that the life cycle stage should be in an acceptable risk state. That's because at least one of the risks of the different parts, occupational and environmental, creates some risks. So I can check in more detail what's happening by going to the alerts page, where I can see that I have a problem in the occupational inhalation part, and then in both soil and water as far as the environmental part. So I can do something to ameliorate the situation in the inhalation part by applying some risk management measures. So if I click here, what we have here is a list of risk control measures coming from the SL library from TNO, courtesy of TNO. So what we have here is this list. We have the name of the risk management measure, upper and lower bounds of the average costs, its efficiency, and the average life duration. We also have these three circles here. The first one is telling me that it is applicable in one of my scenarios. And if I click, I can see that in fact is applicable in the product manufacturing inhalation part. I can also see that one of the scenarios where it is applicable, it's in an acceptable risk state. And in fact, we did know that this was in an acceptable risk. And then it's telling me that it's not applied yet. So I might just apply this technology and see if it modifies the results. But before doing this, it's a good idea to clone my scenario. So I clone my scenario to compare the two. And I say with risk management measures. So now the system reevaluated and copied everything from the first assessment context to this one. And you can see here that we've changed the assessment context. And now I'm happy to apply this technology. So now I applied it. So it appeared here. And this apply button, it has appeared up here. That's because I might select more than one. So I might select another one and apply also that one. So once I'm done with the selection, I can apply the whole set of risk management measures. Let's apply this one. As you can see, the system recalculated and we managed to solve our problem. In fact, the state become green, and if we go back to the results page for the occupational inhalation setting, we can see that now it's in the right, in the green part, the red line. It was before and in the red part. So we can also go back to the comparison page and see that now we have two assessment contexts, one with and one without risk management measures. And we can see that if we have to choose between the two, it's likely we will go for the one with risk management measures, for sure. Finally, another interesting part is the one related to the sharing, like we were talking about beforehand. So if I go to the details of my project, you can see here I have a list of my colleagues or people that I know in the tool. So I can select this one and share with him. So now that I share, now here I am with the other user, this test user, and you can see he received a message here. If I open the message, it says that Alex Travel wants to share this project. I accept. And what I get is the project, exactly the same one. And more interestingly, if I enter a specific part of that, you can see that if I change a value here, it's immediately reflected to the other user. So you can really work simultaneously on the same project and see the results of what the others are doing. And moreover, you can also express something about your project, saying so that you're always in line with your colleagues on what's happening. And I guess that's all I wanted to show in this section.
Great. So thank you very much, Alex, for this presentation and also for showing how the decision support system can work in practice. I do see a couple of questions in the Q&A part. So the first one is from Luis Maurizio, and the question is, which probabilistic method inference is used?
Here the question can be interpreted in different ways. So I don't know exactly which probabilistic method he was talking about, because we have several models, as you've seen, in different places in the DSS, and each of those models is using its own probabilistic method. For example, for human hazard, we are using basically the PROAST method from IBM. But for every model, you can find in the bottom. Now we will have the practical exercise, and we can see it. But at the bottom of every model you're using, there is a reference to the paper explaining the details of the model. If instead you're talking about how we, because then in the system you can also not use models and directly input lower and upper bounds. In this case, we are using log normal for effect and normal for exposure. So normal distribution and log normal distribution, and we are integrating them for the risk. So I hope this answers this question.
Okay, I see. Thank you so much. So the second question is, what are the characteristics of soil, which type is used, and water compartments that the system uses?
So this again is a very specific question for the model about PMFA. So to be honest, I really don't know the answer because it's embedded in the model. So all I can say is that you should go to the link, to the reference link, and take a look on how it was modeled by the modelers. Because in the tool, you can only specify the transport coefficients between different stages inside the model. But then in order to understand the way these flows are managed, you need to go to the reference, because in the DSS we are integrating these models, but it's not that we are developing each model that is there.
Yeah, but I guess the same counts, as you said before. You can see all the references when you're directly using it. So
just look at the reference and you will find the information.
So this is encouraging participants to really have a look at the decision support system and use it actively and engage with it. Perfect. So there is also one question from Burkhardt. Can you also insert a range of different exposure values as input for the deterministic parts?
So this is not really clear to me, because if you have different exposure values, you're not using the deterministic part, in the sense that if it is deterministic, you should have a single value in this system. So it's not taken into account of different exposure values. If you mean that you have different activities that then have different exposure values for different workers, this can be modeled by the creation of different assessment contexts. So you first create the different contexts for the different activities, and then you can input the specific exposures for the different things.
Okay, I see. And then you just compare the different results, how they change. Okay.
Yes.
Great. So that were the questions so far from the live Q&A. To all participants, again, if you have any comments, thoughts, ideas, questions, please put them there and we will try to address them and answer them. And Alex, now will you also show something more?
So the idea now was to try to use the system together. So I will share my screen and ask you to try to follow the application with me. Obviously, live, it's a different thing, so we're trying to doing it online. It means that whenever you have any kind of problem, just write in the chat or raise your hand or whatever you can do to express that you have a problem, and we will try to see what's happening. If you can, just follow the same things I do, and so that you get an idea of how it is applying the system. You should, I'm not sure about this, if you have received 2 Excel files with some data. Great, thank you. So we can use those files to apply the models later on. So let me share my screen. Okay, so first thing you should do is, let me log out. Okay, oh, I don't know how clear it is. I might try to change the definition of my screen. I guess it's too small. So wait a second. Let's try this one. Okay, I hope it's a bit clearer. So we should go to the sans.gd link. So it's also in this slide. So, sorry. This is the URL. So sans.gd. This would bring you to the initial page where you can sign up, like we've seen before. So go for that. You sign up. You input your name, your email, and your password. Then you sign up. You will receive an email. You click the confirmation link in the email so that you are recognized by the system. And finally, you'll be automatically logged in like you have seen in the video. So at some point, I just wait a bit, you should be able to reach this page. Now it's harder to understand who made it and who didn't. Let's wait a bit. Okay. Supposing you made it this far, you can see that the system is divided in 2 parts that are different. One is nanomaterial used in consumer products, and one is nanobiomaterial used in medical devices. So we will go for the medical devices and the ATMPs. Again, the system is divided in 2 parts, like you've already seen. Let's go for the risk assessment and risk control. Now, I have a lot of projects here, but your page should be empty. So basically, Okay, it's the same page without any project. As we said, the project is a container for all the information about something. So we should create a new project for this exercise. So we just click the plus button. We enter a name, for example, sunscreen cream. In this case, I specified also the type of nanoparticle in the sunscreen cream, but as we've seen before, it can also be that I have several different possibilities. So I can create my sun cream with silver, but also with something else, and I want to compare them. In that case, the name of the project should just be sunscreen. I can also include an image for my project. I just drag and drop. So now you can see I have my project in the list. Maybe it's better like that. And here you can see the name of the person creating the project. So these are my projects. This comes from my colleagues, and we can share them as you've seen previously. Once we enter our new project, we are asked to create assessment context. So first of all, we should select what we want to compare, and then we can create our first context or scenario, as you prefer to call them. So for this exercise, we keep it simple. I hope you all reached this point, but I see no questions, so I guess it's like that. If you have any problem, just write something. We can try to help you. Or maybe it's here. Oh, I don't know. Okay, so then if I enter the occupational part, let's pretend we only have the synthesis part, and let's click inhalation and inadvertent oral. So for the occupational setting, we will only look at these two routes. And for the environmental setting, again, we only look at the synthesis. And let's look at sediment and water, for example. So now we decided that we want to compare our assessment context only according to one life cycle stage and two routes and two matrices. We can add whatever we want. We can also select all of them, but let's keep it simple now. So now I can create my assessment context. I give it a name. So it's, let's call it standard production. I can specify some other characteristics that will help me identify this specific context. So it's silver. I can specify nanometers and whatever I want to use in order to identify this context. Characteristics of the product, of the process, and the operational conditions. I can specify everything here. So a context is broader than an exposure scenario because it also includes the materials that can be different, risk management measures can be different, and many other things. So now I can save my context. And now I am in the assessment context selection page. Again, hopefully you're all here. Not sure. Then we should start working on this scenario. So on the standard production of my sunscreen cream with silver nanoparticles, or nanoparticles of 20 nanometers, for example. So I can enter this context and go to the risk assessment part. and start with the environmental exposure. So in this case, you can see we have the PMFA model, but as this model is rather takes some time to apply, it's easier just for this one to input manually the values. So we can, for example, say that we have for the sediment a lower confidence limit of 0.01, for the upper limit 0.06. Same goes for water, and let's have bigger numbers than 1 and 3. So what happened now? We specified the numbers, and the system evaluated automatically a distribution because we didn't apply the model, and in this case, it's a normal distribution for exposure. If you did this, you can see that we only have a sediment and water, like we said before, because these are the two matrices we decided to use in the assessment tree. And then we can move to the effect part. Again, you should see sediment and water. In this case, we can run the NSSWD model. So let's, for sediment, enter the interface. In order to use data for the model, we say that we don't have field data directly available, so that we have to evaluate the species sensitivity distribution from the NOx. And we move to the next step. And here we can try to apply. So we have different settings here, but we can live with the default values. We have no input data, as you can see. So this is the first moment when we shall use the data that was provided to you. So if we click the upload, you go and find out the NSSWD data synthesis water file. Then you should just drag it and drop it. Once the upload is concluded, you just click OK. And now you have all your inputs loaded in the system. Okay. Okay, now that we have the data loaded and we decided for all the other parameters, we can, so what we were talking about before, and it's here you can find that there is the complete reference to this NSSWD package, and it's there for every model you're using in this DSS. So if you need more information about specific models, you just go to the reference and find out. We can then run the model. We can take a look how it is performing here. And you see that the model just started, but it's taking a while, maybe because all of us are running this model in the server. So we don't have to wait for the model to complete. We can continue working because the model is running in the server. And so we can go on with our assessment and see if it completes. Sorry, I went to the wrong one. So we were in the effect part. So as far as sediment, the model is running. So we just have to wait until it ends. For water, we simply input numbers manually. And in this case, for the effect part, we can say just 2 and 3. Just to have some numbers to play with. So in this case, the system directly updated and calculated the results because it's not applying any complex model. So we can now move to we can take a look at the results already. So if we go to the results page, we have to go to the environmental setting, where we can see for the sediment, we only have synthesis, so there's nothing to choose as far as life cycle stage. For the sediment, we have this automatically generated curves using the numbers that we provided for lower and upper bounds. The effect is still under assessment because you remember we ran the model beforehand and it's still calculating, so there is no risk, no effect. But you see that the model completed and the system automatically updated live. So now we also have the effect curve calculated with the model. We can see the results here. So the specific detailed chart about species sensitivity weighted distribution. So the usual SSD chart. And also the predicted PNEC versus the one that is calculated. So we have several kind of results available for each specific step. And also we have our risk calculated, and we see that we are in this uncertain area. So if we can find a way to reduce uncertainty in our data, we will probably move to the red or green part. In fact, the green line is the probability of the risk characterization ratio, as we've seen before. So we can also go to the water part. In this case, everything was immediately available because it's all coming from the inputs we gave manually. So we can see both here. You can see we don't have the other charts for the effect of water because we manually input them. So we don't have all the detailed results we had for the application of the model. And again, we can take a look at the risk. And in this case, we can see we are in the red part. Then sometimes I check if there's something new here. Then in the occupational part, we go into the exposure. Again, in this case, we can apply the occupational inhalation model. I think we can keep the values here, but for example, if you know your the mass used in your assessment context, the duration of the task. So this is something you should specify, and that's what we were talking about when we were talking about the activities and the workers. So you just specify the specific values for your room and the work that is performed, also the activity that you are performing, and then you can run the model. This was much faster. And it calculates two deterministic values, as we've seen before, and those go back in here. So we have the lowest of the two for the highest for the exposure. Then for inadvertent oral, we have a different model. And again, if you have information about these numbers that are required for the model to run, you can update. Otherwise, for this kind of models, you can live with the default values, and it also works, and you get your results. So as far as exposure, you should have your exposure evaluated in the system. Moving to hazard, it requires a bit more work because we have to define biomarkers. But let's enter the model application. We can define this as a chronic exposure, for example, and select repeated dose toxicity as an endpoint. So we created our biomarker for a specific endpoint, and we can now apply the model. So obviously we say we don't have a point of departure, and so we need to estimate it. Again, we have to input data, and we will use the data file that you received. So same process. I upload. This time you choose the dose response file, and you input in the system. And again, you have all your dose and response data imported in the system online, and we can go for the calculation. And again, this was quite fast. Then let's go back. Oh no, sorry. Then it could also be interesting to go to the second stage, so the application of assessment factors. So this is using the Approba spreadsheet by WHO, and there's a link directly to that because this is freely available. Some part of data is deriving from the previous calculation, so we shouldn't touch them. We can change again if we have information about where this study come from, whether it was chronic, on which species. So we can specify different assessment factors here in order to derive the value that we are interested in. We can run, and we get the UC, the DNL upper and lower bounds. So this was calculated automatically, and we can see we only have in this case one biomarker. So this could be obviously very representative for the whole inhalation part, and we can see it here. And for the inadvertent oral, I think we should go for the manual insertion of probabilistic values. Let's say between 1 and 5, for example. So I hope you are more or less in the same condition as I am. Then if we move again, okay. If we move up again to the results page, we move from environmental to occupational. For the inhalation, we see we have a deterministic exposure because it was like that from the model. We have here, this is not a probabilistic distribution, but it's the distribution in time, you can see, for near field and far field. So these are specific results from the model. Same goes for the other part. This is the final linear distribution, but we can also take a look at the fitting model and the distribution of the BMD, and also the sources of uncertainty here. And finally, we can go to the risk. So we can see we have some risk here. We can also compare the DNL, the deterministic exposure, and the DNL distribution, and so why we got this risk. And again, what is generating most of the uncertainty. We also have all the information here below. So same goes for the inadvertent oral. In this case, it's much safer. And we can also take a look at the comparison, but this one is so small that it's not even visible. So now we should also go and see the risk control part. So for comparison, it's more interesting if we have more than one assessment context. We now have only the standard production one. So let's create a new context. As we've seen before, if we go to the alerts, we can see in a glance all the risks, unacceptable risks, and the risks that need further consideration, all in a single place. So we can see that we can do something for the occupational inhalation part, because for that part we can apply risk management measures. So we move to this part. We now have the complete list of management measures loaded. And we can see that, for example, the glove bag, it's applicable in 2 cases, for inhalation and for inadvertent oral. Now, inadvertent oral is already in a good state, so we can apply for the inhalation. That was the initial idea. But before doing that, we clone the scenario. So we create another one that is standard production with a glove. So what happens now is that the system creates this new scenario and it takes me to that. In fact, you can see it here, standard production with glove bag. And now we can create and apply risk management measures. So I can go here and say that I want to apply this one. So now it's applied here. We can add other risk management measures, but let's try with this one. And we can click apply. So what's happened is that we applied the risk management measure, it worked, and it was enough to create a situation that is acceptable. So let's go back to the comparison. So now in the comparison tab, it's clearer that it's simple, that in the synthesis lifecycle stage, the standard production with the glove bag is better than without it, as far as risk assessment. We can also take a look from here and see how we have some in the environmental part, we still have a risky situation because we didn't apply anything there. But if we go to the occupational, we can see that in the standard production, we can have problems in one of the areas, while if I apply risk management measure, everything went fine. Yes, the thing is finished. I don't know if you have further questions, because I'm not sure you were able to follow me. So if you have questions, please ask them.
So thank you really very, very much, Alex, for this guided use of the tool. I think this was really helpful, and I personally highly appreciate that you did this exercise with us, because I think especially with tools like this, they seem to be a little complex and you need somebody that explains it to you to really make use of it. So I think this was a really nice interactive way to do it. Tricky since it's only online, but you managed well. So congratulations from my side, and thank you very much.
Thank you.
I'm checking the Q&A chat. So far, we didn't get further questions. So one last time, I highly encourage now participants, if they want to share any comments, thoughts, ideas, questions, do it now, so that we can make use of Alex and ask him as the expert. Maybe in between, I can ask you something, Alex. Yeah. So I know that this tool is heavily refined and further developed in the Biorima project, but I also know that this project will end soon. So sure. Maybe you can give a quick outlook. What will happen? Do you still plan to further expand it, or is it more or less set now as it is? And yeah, any ideas on further working on this?
Yeah, that's a nice question. Thank you. First of all, before the end of the project, we will include also the part on the IATAs that is still not developed now, but it's under development. So it's not visible to you, but we already have something in there. And so you will be able also to apply that part and understand which kind of assays you should perform in which order and things like that. So that is part of Biorima, and it will be there by the end of the project. But then we are also planning to continue the development in Sunshine. So include other models and other assessments, include all part of characterization of the nanoparticle, because up to now we only focused on the effects and on the hazard, but you're not inputting the characterization of the nanoparticle. It will be there because part of Sunshine is also grouping and read across. So one of the models available in the system will also be a model for grouping and read across, and that should help. And we are also planning to create a more detailed activities setting, so that you can specify more clearly the different activities going on in each context. So yes, the system is we're looking forward to improve it and enlarge it in the future.
Okay, that's really cool. That's good news, because sometimes when the project ends, the activities also end, which is sad and a pity sometimes. So happy to hear that there will be also more to come.
Thank you. Yeah, we are happy too.
Great. So let me check if we got a question. I think no. So Alex, would you like to do a very quick wrap up for the last 2 minutes? Do you have any take-home messages that participants really should take with them out of this session?
Well, one thing I would like them to take home is to remember that the system is completely free and it's available to them. And we are we would love to have feedback from them. I can understand it's not easy to apply it now with this live section and look at the screen and simultaneously apply on your screen. So again, if it was live, it was different, but we went fine anyways. So I would like to encourage you to try and use it and send us feedback if you find out something that you don't understand or that you don't like. And obviously, if you have nice features or interesting things that you would like to add or you think should be there and they are not, we would really love to know, to have some interaction with you, some more than what we had today. So that's the main message for me.
Perfect. So I think that's really good closing remarks, and it's good news that everybody can use this tool also at a later point. So there's one thanks to you, Alex, also in the discussion forum from Masa. So yes, I don't have anything to add at this point. So thank you very, very much for your time and for your efforts. And it was a really interesting session. And yes, I also encourage participants to have a further look on the tool and maybe also engage with you.
Thank you.
Okay, great.